So we're going to talk about API security some more and how to weave that security all throughout the life cycle, but especially early on into the life cycle. A little bit about me. You might have seen me this morning. I'm one of the co-founders of APISec University. This is a site that we launched a couple of years ago. It was kind of just a crazy idea that we had to make a couple of courses. We just threw them up on the internet. And within a month or two, we had 10, 20,000 students enrolled. You can see all the courses here. We started with this pen testing course. It's our most technical, our most sophisticated course. Jakob actually made our last one there, API authentication. We've got over 90,000 students. So it's just been a really remarkable destination. It's all free. There's nothing salesy. There's no pitches. So come check it out if you want to learn more about API security. Now, I always like to start with some stories. You probably heard me tell a few this morning. So I'm going to tell you how you can make a 4,000% return on your investment in one API call, okay? And this worked, okay? So there was a hacker, and he wanted to poke around on the Coinbase platform. All right, Coinbase is where you can buy and sell Bitcoin and crypto and things I don't understand, right? And he wanted to look at all the API calls and see if you could do some manipulation, find a vulnerability, something like that. And what you see here is what the traffic looks like when you do a trade on Coinbase, right? And in yellow, you see the parameters. You've got the base size, that's the quantity, right? The limit price. The product ID here is Ethereum on the European market. So he actually owned that, right? And you see he's on the sell side, and then a source account and a target account, okay? Now, what attackers like to do is send ridiculous requests in order to see error messages, right? As Axel just pointed out, sometimes our error messages are revealing, right? So he backspaced over Ethereum, which he owned, right? He already spent $1,000, bought 0.024 units of Ethereum, and he wrote Bitcoin instead, which he did not own, okay? Hit submit and waited for the error message. And did not get an error message. What he got back was a trade confirmation. And his $1,000 of Ethereum sold as $43,000 of Bitcoin, right? And it actually worked, right? He probably thought he was going to prison, instead went onto Twitter and said, does anybody know the CEO's email? Because this vulnerability is potentially market nuking, right? And he didn't go to jail. Coinbase gets a lot of credit. They immediately shut down the market. It was closed for 24 hours. They reproduced the issue. They fixed the issue, which was a simple input validation, right? Or BOLA, depending on how you want to look at it, right? And they rewarded him with $250,000 bug bounty, right? So it's just I like to tell this example because what's happening here? It's not an authentication flaw, right? Didn't brute force his way in. This is a logic flaw on the API, right? So these are the kinds of things that are happening out there. This is from about a month ago. TracFone is owned by Verizon Wireless in the States. They were leaking subscriber data through APIs for years. And they performed an investigation. The Federal Communications Commission's just issued this report. You can go find it at that big, long URL. $16 million penalty, plus they mandated all kinds of requirements, including mandatory, continuous, dynamic, static testing, prioritizing APIs to look for vulnerabilities, right? And we've been talking about the need for better testing quite a lot in the sessions here today. So that's just from a month ago. And to give you a feel for like what's going on in the broader scheme of things, this is just a sampling of all the breaches that we could find out there, right? This is over the last few years, and what stands out to me on this list is, A, the sheer volume of API attacks. Every one of these is an API breach, right? Look at the volume of records, 10 million records, 100 million records, the entire LinkedIn database harvested through a leaky API, right? And these are sophisticated companies, right? They're not, mom and pop shops. They have best technology, best people, and somehow these API attacks are making it through, right? So we wanted to look at that, and we analyzed all those breaches, and we tried to come up with, like, are there certain patterns that are standing out in these attacks, right? Certain things that are coming up more often than others. And right at the very top, well, when you look at this screen, the first 4 definitely dominate, right? They're much more prevalent than everything else, right? And at the top, you see rate limiting. Almost 70% of the attacks involved rate limiting, okay? And you might say, all right, our best defense here is to improve our rate limiting, right? We need to shrink it, make it tighter, more restringent, whatever, right? But that's not really the solution. And the reason why is rate limiting isn't the core problem, right? It just makes the core problem worse, right? The core problem is you've got an API revealing something of value, right? If there was nothing of value, you wouldn't try hitting that API 500 million times. You wouldn't try 50 times, right? And your attackers know you've got rate limiting in place. They are clever. They are determined. So what do? They ratchet up their requests until they get blocked, and then they dial it back by 10%, right? They just fly under the radar, and they can stay there for months, and they can parallelize, they can distribute, use IPs, residential proxies. Rate limiting is a velocity limiter. It's not a volume limiter, right? And your attackers are determined. So this isn't the core problem, right? In fact, it kind of highlights the limitations of rate limiting as a defense, right? You should do it, but don't think that you're safe because you've got it. So if that's not the core problem, then what is? And it turns out that the next 3 items, which not coincidentally are OWASP 1, 2, and 3, were responsible for 90% of the breaches on that last slide, 90%. And what that suggests is if you can address OWASP 1, 2, and 3, you've made a huge impact on the security of your APIs. And what are we talking about? If you're not familiar with OWASP, definitely come check it out. We've got courses on it. It's fantastic guidance on the risks that APIs have. But OWASP 1 is broken authorization. Most commonly, can user A access user B's data, right? That's OWASP 1. OWASP 2 is broken authentication. And I don't see a lot of like password cracking and all that kind of stuff. I see no authentication. Like there are tons of examples on that last slide of APIs with 0 authentication on it. It's just the door is unlocked, it's wide open, anyone can use it. And OWASP 3 is excess data exposure. Right? Are your APIs revealing something of value to those end users? So address those 3, and you have made a huge impact. So we talk about this life cycle of an API, right? And there are lots of different things you can do to implement security throughout this life cycle. So let's just talk a little bit about that, right? So at the far left, this is like API is born, right? We're all sitting around the whiteboard, and we're talking about this new API. Hopefully security is in the room at this point, right? And you're sketching it out, and you're talking about like what kind of data, what is it doing, what are we going to do, right? So this is where you start to integrate security into the earliest stages of your API creation. Make sure security is in there, or somebody who's security savvy. Then you go into coding, right? So you've got this design sketched out. Now we're coding it, right? So you're doing all the standard stuff you do, code reviews, right? Static code analysis, composition analysis, all of these kinds of things, right? But those automated tools are going to look for common vulnerabilities, right? Injections, cross-site scripting, tools, things like that. And hopefully your code reviews are going to think about those more complex, those nuanced, those logic flaws, right? Now we've got a built app. We're going to go put it into QA and testing, right? And we'll talk more about how we go about testing, but it's largely manual or some legacy tools that we've got. All right, once it gets out of testing, it goes into deployment. We're now throwing it into the gateway. We're managing it. We've got monitoring tools in place now, so your web app firewall is watching it. The gateway's doing its rate limiting. Maybe you have a SIM or some other security detection technologies out there. And then we retire it, right? So hopefully we retire properly. We actually deprecate old versions that don't need to be around and so forth, okay? So that's the life cycle. Right, and I want to talk to you about some of the challenges, specifically around testing and monitoring, which tend to be the 2 main approaches for security, okay? See how I'm doing on time? All right, good. So the monitoring challenge, here's the problem with monitoring. API attacks look legitimate, right? And I'm going to give you a couple of examples to hammer this point, right? So here's an example of a request, right? So we've got a GET request to user ID equals blank or 1 equals 1, okay? I only just learned this. This is the most basic SQL injection attack that there is, right? 1 equals 1 for me, for Travis, for Axel, for everybody, right? And if I'm vulnerable to this, it will return my entire user database, right? Because 1 equals 1 for everybody. But this is very obviously malicious. Your WAF will 100% block this, and nobody gets breached this way, and if you do, shame on you, right? There's lots of ways to prevent that. Okay, obviously bad. How about this? User 10, and let's say user 10 is fully authenticated, good password, everything. They're going to do a delete method on transfer 123, okay? Everything about this is valid, right? The user, the legitimate user, they're properly authenticated. Delete is a valid method on the valid transfers endpoint, and 123 is a valid transfer ID, okay? But what if transfer 123 doesn't belong to user 10, belongs to user 11, right? And this is the fundamental problem, right? The attack looks completely normal to your runtime defenses. And it's almost impossible to detect that in the 2 milliseconds that you give your WAF to make a judgment, right? That's the monitoring challenge. And when you think about all those breaches that I showed you on that slide, all those attacks got through the defenses. And this is the main reason why. So let's talk about testing. So testing challenge is really a volume problem, right? Here's just some food for thought for the types of testing you got to think about. Security testing, right? Unsecured endpoints. Are we leaving the door unlocked, right? Are we using incremental IDs that are convenient for developers but super convenient for hackers, right? Have we run injections and cross-site and fuzzing and all these kinds of things? Then you got next layer up, data, right? So what kind of data is our API touching? What kind of data is it returning? Is there PII in here? Is it too much data? Is there compliance issues? How are we controlling that data? How do we make sure it doesn't get in the wrong hands? And then the highest level, this is the hardest one, is logic, right? Like, can I sell my Ethereum as Bitcoin? Right? How are we going to detect that? How are we going to simulate that? Can I access, Joe Biden's Peloton records, which is a true story, right? There are so many different logic scenarios to think about, okay? So let's just talk about the options that are available to you. So in testing, you have 3 options. Option 1 is do nothing, right? And I won't ask you to raise hands, but I'm sure a few of you are thinking to yourself, that's our option. That's what we do, right? It's hard, right? Option 2, do it yourself, right? And what am I talking about? By hand with tools like OWASP Zap and Burp and Postman and things like that, right? But that requires high level of sophistication, right? They're great tools, don't get me wrong, and you have to have a lot of time, right? So that's option 2. And option 3 is get someone else to do it. Right? And we're talking about like a pen test firm, red team, bug bounty, something like that, right? Problem is, they'll come in once a year, they'll hack your systems for a week, they'll give you a report, and then they go away for another year, right? So I want to show you another option. So let's see if demo gods are going to play nice with me. So we built a technology that does automated API security testing. Right? And the way it works is, where happened to my mouse? Here we go. We'll do this here live. So I'm going to take an API spec. And if you're not familiar with crappy, that is a completely ridiculous API. That's what it's called. Where did it go? Here. Oh, can you put that up? Sorry? I have to switch myself. All right, maybe I have to do it like this. All right, let's go back. Okay, there we go. Now you can see. Thank you for letting me know. So we're going to add an application, an API here, right? We're going to start with a spec, and we're going to use crappy, which is, here's just a Swagger file. Whoops. And we're going to drag that in here. and we're going to load it. And of course, I haven't given it a name. Let's just call it ASDF. There we go. So what it's doing now is it's pulling up that spec, and it's analyzing. And you need two things if you're going to run a test. You need a spec, and you need to know where it is. Right? So it's looking for the base URL, and here it is. It's hosted at crappy.apisec.ai. Now, what's happening? It's ripping apart that spec. It's building a model of your API. Right? That model incorporates the endpoints, the parameters, the payloads, right? The methods, the authentication, and it's creating this whole attack suite, right? Right here, what we've done so far is nothing but static analysis, so you can see like the composition of your API, which endpoints are authenticated, which are not. This is kind of cool. We actually compute a sensitivity. So this is looking at every endpoint that you've got, and it's looking for like which ones are doing sensitive operations. Right? So for example, I don't know, let's look at this one, change email. Right? So it's saying, all right, you might want to pay attention to this endpoint, right? It's where I can change the email address from one user to another. Right? So it's done this sort of AI like language model analysis looking at parameters and payloads. Now what I'm going to do to sort of parallelize things, I'm going to go ahead and launch a scan. Okay, thank you. So what is going on here? Well, we started with this API, and it's nothing more than a spec. Right? We've been able to sort of examine and understand what this API is made of, right? But then take a look at this security coverage. Let me go back. This API has 42 endpoints. The engine produced over 1,500, I know it's tiny, 1,500 different test scenarios already, all right? And what are we talking about here? You see here, headers, right? So we're doing cores injection, HSTS, rate limiting, right? Injections, right? NoSQL, PowerShell, reflected injections. You'll see things in here like info leak, right? Network leak, server leak, PII, stack trace errors, incremental IDs, and on and on and on, right? Authentication test, BOLA test, authorization test. All of these types of scenarios have been simulated on your API, and you don't have to sit down and write a single one of them, right? So this will complete here in just a second. While it's doing that, the next thing that we'll want to do is authenticated tests. I haven't created any credentials or users or anything like that. So the next step would be, let's go create a user A account or test account or whatever it might be, so we can do authenticated scanning on your API. And this is completed, and here we go. In that amount of time, we've identified 3 different categories of vulnerability here. You can come in here and take a look at any one of them. It's going to tell you exactly what went wrong, why did that trigger a vulnerability. You can see all of the calls and responses. You can even export this as a Jira ticket, as a curl command, and so forth. So that's the tour, right? The main thing I want you to get out of this is, yes, you can automate this type of testing. You can get that deep simulation of all those different scenarios, and you can integrate it into your CI/CD pipeline, your Jira ticketing system, and so forth. So that's the tour. The demo gods were nice to me, so thank you. Let me just wrap with a couple of QR codes. I promise these are safe. Or you can just go to the URL there if you want to do it that way. But if you want to try it out, it's all free, right? Like the rest of our courses and everything else. So you can definitely go and try out this tool on your own API. We also are hosting 2 weeks, roughly 2 weeks, we're hosting for October Cybersecurity Awareness Month. We've got a webinar on this very topic of API testing and how to automate that, make it as comprehensive as possible. And that is it. There's my email. If any of you want to follow up, please don't be shy. Thanks so much.